Hey there, all you cool cats and kittens. I just might get a kick out of that one. Bear with me on this. This is something we've never had to do virtually. I'm going to give you one assignment a week. Attempt to do it. You know, try to keep your brain going. Try to do this stuff. And I understand sometimes we may not get a chance to do it. We may not have internet. This may not be able to help us. I'm going to put some stuff on Google Classroom that goes along with telling you how you can get on Zoom and ask me questions, or if you need to get in touch with me by email, if you have questions on something we're doing, just bear with me on this. I'm going to go through one thing a week for you. You know, we left off, this is where we left off, we were talking about solutions. So I know it's different, it's a change, it's something we've never had to do. I understand that. Don't get overwhelmed. I'm not going to overwhelm you. If you have any questions, please don't hesitate to contact me. You guys all know my email. You can get in touch with me through Google Classroom, and that's the way we'll be running this thing. So let's just go. You know, today we're going to talk about 6.4. We're going to talk about, you guys have your notes, 6.4, making solutions of varying concentrations here. And if it may be tough to see, we'll just kind of see how this goes. When it comes to using the TV, I want to do it this way, just like you would be in class. I'm going to do some stuff on the board over here. So in just a second, when I come over, I'm going to have to move the camera for myself here to get it to the whiteboard, and I'll also use the ViewSonic board. All right, so 6.4, concentration. We talk about concentration. We talk about making solutions of varying concentrations. You see here, we've got our funny meme. What do you call a tooth in a glass of water? Oh, another solution. So pretty cool, especially with the hey there all you cool cats and kittens that we've seen over the past couple of weeks. All right, first thing, molarity versus molality. I would take out my notes just like we do in class, and I would highlight. Molarity and molality. When we talk about molarity, molarity is going to be volume, the volume of a solution. Molality deals with the mass. I will tell you this, we will not do anything with molality. When you go to college, you'll do very little with molality. Even our AP chemistry stuff, we didn't really talk about molality a whole lot, but molarity is where we need to focus. It's where we need to focus our attention when it comes to this. But molarity, like we said, we want to think volume, the number of moles in a 1 liter of solvent per solution. Now, that 1 liter solution can change. It can be 500 milliliters. It could be 100 milliliters. It could be that 1 liter. It could be 20 liters. It could be any number you want it to be, but the basic concept of molarity, though, is the number of moles in 1 liter of solvent per solution. Just kind of back up a little bit. And I know it's been a little while. I'll talk about solutes and solvents. Remember, the solute is what is being dissolved. The solvent is what is doing the dissolving. We put it together, we make that solution. The molarity there, like it says there, is equal to moles per liter, and it's equal to the amount of solute per moles. If we look up here on the board, molarity is the volume, molality is the mass. Again, don't get them confused. It's one letter that is simply the difference in those terms right there. It's the difference between the R and the L, but it's a huge difference. So you need to make sure when you think about your vocabulary, you think of molarity. You don't think of molality. Now, with molarity versus molality, we talk about this, we say a stock solution here. A stock solution is something like what we use in the lab. If we would have been able to do our lab aluminum leftovers, if we would have been able to do that lab, then we would have been able to do this in class. We've been able to see it firsthand, hands-on experience. Aluminum leftovers is a really good lab. I know it stinks that we're not getting to do it, but this is the best we can do. But we talk about stock solutions. You see this here with this stock solution. This is hydrochloric acid that we see here on the picture. When we go in the lab at times, we have seen where we have used 1 molar hydrochloric acid, or we've used 6 molar hydrochloric acid, and each one of those things vary. Obviously, the one with 6 molar has a higher concentration than the one with 1 molar. We've talked a little bit about hydrogen peroxide. Hydrogen peroxide, what we buy at the store, we've said is 3% hydrogen peroxide. What you maybe get your hands on in the lab could be 10% hydrogen peroxide. So the concentrations vary. And I want to bring this up to you. Speaking of concentration, speaking of solution, we talk about soap right now. Soap is a huge thing for us with this coronavirus, with COVID, in washing our hands. The more higher concentrated the soap, the better off you're going to be. Because I'll tell you one little fact here about the coronavirus, about COVID. One way that COVID is being that it doesn't stand a chance against soap and against things that break it down is because it has on a virus, on a cell, the virus cell that you see there of the COVID. You've seen it, and it looks like the crowns and all that stuff. That's why it's called coronavirus, because of the way it looks like it has a crown on top of it. But one thing that breaks it down, though, is the soap. And the reason is because the outer layer has a layer of fat. So when you use a higher concentration of soap, therefore, it breaks that fat down as we create those suds. And when we create those suds on our hands, we're washing our hands, those suds get created, and that fat breaks apart, and then therefore it destroys the coronavirus. That's why it keeps it off of your hands. Think about this. When you wash your hands, put a little bit of water in your hands, and then put the soap in your hands, and lather for 20 seconds before you even put your hands back under the water. Because as soon as, one thing you can do wrong is put the soap in your hand. Once you put the soap in your hand and you're washing your hands underneath the water the whole time, you're diluting it. And that gets us to the next thing, in making a dilution of a concentration, all right, whatever that concentrated solution is. So the higher the concentration of soap, the better chance you're going to have to be able to break down that fat of that coronavirus, of the COVID, and making sure that we stay safe, all right, we stay healthy. So that's just something there to kind of relate this back to the things that's going on in the world right now. So make sure you highlight what we said molarity was. Molarity equaling the moles and the liters equals to the amount of solute and the amount of solute, which we measure in the mole. We talk about, go down, I told you we would skip molality. The next part would be the dilution and to dilute something. This is the process of adding water to a stock solution to lower the concentration of that solution. So it goes back again to that example I gave you. Make sure when you wash your hands, you're not constantly just having your hands underneath the water to break down the degreaser that's in that soap that breaks the fat down. Think about when you wash dishes. We use a higher concentrated soap when we wash dishes to break the fats off the plates. So that's one thing we want to be able to do there. The next thing, we talk about making a molar solution. When we make a molar solution, this is where I'm going to pan out right here in just a second, and we're going to do, I may move it over here to this board if that's what we'd rather do, and we're going to work some problems. We're going to talk about what our calculations are to be able to find this. So just bear with me here for a second. I'll pan it over here. Okay. All right. So when we talk about this, when we do these problems, we're going to have our equation. Molarity can't write. Is going to be equal to the moles of the solute divided by the liters of solution. Okay? So molarity is equal to the moles of the solute, what we are dissolving, divided by the liters of solution that we see here. And we'll be given that liters of solution. Or sometimes you may have to find it. And sometimes you may have to find what the molarity is. Sometimes you may have to find what the moles is. Sometimes you may even have to find what the grams are. When we find the grams, it makes it real easy because we know we went from grams to moles this year and we went back from moles to grams. So our simple process there to be able to do this. Now, when we talk about finding molarity, what we had on the PowerPoint up there a while ago, got a couple problems here. And we posted a few of these things. When it came to molarity, we posted a little bit of this before we left, and we really had the unknowns of the past 2 weeks, thinking we might get to come back, but hey, we're not back, so this is what it is. So this is really the first part of that packet, so to speak, that I gave you before we left to go, before we left for the virus and being out of school. So let's just go to question number 1. Question number 1 in that packet of what I've given you. Number 1 said, what is the molarity of a solution in which 58 grams of sodium chloride are dissolved in 1 liter of solution? So you can find that here on that sheet of paper that I posted for you. I'm just going to do the problem. I don't want to write the question up here, but the first thing we have to do, step number 1, is to convert, on this one, we have to convert grams to moles. Okay? We have to convert the grams to moles. Step number 2, all right, after we find step number 2, when we convert the grams to moles, we will plug it into, plug our moles into our equation, which is very simple. 2 steps here. Some of you may have done a little bit of this, but I'd rather talk through it with you for just a second, just to make sure you understand it, to make sure you know how to do it. So what is a molarity solution in which 58 grams of sodium chloride are dissolved in a 1 liter solution? 58 grams of sodium chloride is what we are given. Remember our dimensional analysis. Our dimensional analysis, what we're given, what we want, goes here. All right, remember our given goes down in the bottom right hand corner again. So we were given 58 grams of sodium chloride. 58 grams of sodium chloride to how many we want the moles of sodium chloride. If this was grams of sodium chloride, this has to be grams of sodium chloride. Okay? Now remember, to find this grams of sodium chloride here, we just go find the molar mass of it. We know the molar mass of sodium is 23, we know chlorine is 35.45. We add those two things together, and we know that we're going to get 58.5 grams of sodium chloride is equal to 1 mole, which equals 0.99. All right, moles of NaCl. All right, 0.99 moles of NaCl. So we are given our moles. Now, like we said, we have to plug those moles, just plug it into our equation. So the molarity of the substance is equal to the moles of the solute, which was 0.99 moles of NaCl. In your problem, you were given liters of solution. Liters of solution was 1 liter of sodium chloride. 0.99 divided by 1, obviously we know is going to be 0.99. Now, when we deal with molarity, molarity is a capital letter M for its abbreviation. Okay, and that's what we put it in. That's our units. So that's problem number 1 on that fact that I gave you. I want to do problem number 2 and 3, and then we're going to work through a dilution problem. And after we work through a dilution problem, that'll be the last part. Now this next one, I'm going to erase this because you can go back and you can rewind it. You can play it again. I'm going to upload this to YouTube. You can go back and you can watch me do that problem if you need to. Like I said, bear with me, guys. Never had to teach to an empty classroom. It's different, obviously. So I'm just trying to do the best I can here. Question number 2, what is the molarity of a solution in which 10 grams of silver nitrate is dissolved in a 500 milliliter solution? So again, we go back through, we use those same steps. The first thing we have to do is take that 10 grams of silver nitrate and it has to get converted to moles of silver nitrate. Again, the grams of silver nitrate is what we have. Remember, find the molar mass of the silver nitrate. The molar mass of silver nitrate is 169.9. It is still equal to 1 mole of AgNO3. It's really odd. They call them foam. Imagine that. J-Dub, John Williams. Alright, so we go from this, 10 grams divided by 169.9. We get 0.059 moles of AgNO3. So that's our moles. Now with our moles, again, remember we plug in our equation now. Molarity equals the moles of the solute over the liter of solution. So the moles of the solute, molarity, was equal to 0.059 moles of AgNO3 divided by, this one changed, it was in 500 milliliters of solution. This always has to be converted to liters. We were at 500 milliliters. We know to convert this, all we have to do is move our decimal place 3 times, and it gives us 0.5 liters. is what we get. We divide that, we plug and chug, we get 0.118 molarity thereof silver nitrate. This is what we would have done in aluminum leftovers. This is the kind of stuff we would have been doing in our lab, but obviously we're not here to do the lab. All right, question number 3. I want to go over question number 3. You'll do question 4 and 5, and then I'm also going to give you a few dilution problems. I'm going to go over one of those. After I go over one of those, I will post a few questions for you to do. Wednesday at some point, I will have a Zoom set up, so if you have any questions, you can get on there and you can log on for those of you that are doing the work. Question number 3, how many grams of KNO3 should be used to prepare 2 liters of a 0.5 molar solution? So with this one, now we're looking for grams. So we're just working backwards. We're working backwards from everything we've done. We're gonna solve, and we're gonna say that this is X of what we're looking for. All right, X is what we're looking for, but it's still the moles over 2 liters that we have, which was equal to 0.500 molarity. This is our equation that we had. Moles of solute over liters is equal to 0.500 molar. All right, molarity. So these two things we have here. Once we have these two things, they're set equal to one another. We know we can cross multiply. We cross multiply 2.0 liters, 0.500 molar equal to X, which is our moles, which we know comes out to be 1.00. And we were looking for, again, X is the moles, so it's 1.00 moles is what we're given here. Okay? Moles of KNO3. Now, let's just keep working. We're given moles, and we know we've always been able to go from moles to grams with our basic stoichiometry. So we're given 1 mole of this, so now we got 1 mole of KNO3, potassium nitrate. This is moles, so here we must have moles of potassium nitrate. When we have that, we have to go find the atomic mass of potassium nitrate, which is 101.1, which is equal to, obviously, 1 times that. This is what we would need if we're going to the lab. And this becomes more ideal for us when we do the problems this way, because typically when we get our stuff, it comes in a solid form. We have to weigh things out. We use the analytical balances. Once we use the balances, we can figure this out. If you worked in a lab, if you did something of this nature. Things that people are having to do right now is they're making solutions to try to combat COVID. So it's just something that is used on a daily basis. Okay, I'm going to swing back to the PowerPoint here real quick. I hope you can see that. Maybe I can zoom it. Like I said, this is the first one I've done, so bear with me here. I'll write a little bigger on the next one. The last thing, we talked about making a molar solution, making a dilution of solutions. So we go back to what we talked about with any time we want to dilute something, we add water to it. Here we see we're adding this water with the volumetric pipette. We've got the mark in the line containing the desired solute is measured from a solution of known concentration. So we have to know the concentration. We add the water. Once we add the water, therefore, we make that concentration either go up or we make that concentration go down, depending on what you want to do with this problem. Now, zoom back to this side. And here, when we do this, just a few more minutes. I know we're 19 minutes in. We've seen something that looks like this when we talk about dilutions. Dilutions. Molarity of 1, the volume of 1 is equal to the molarity of 2 and the volume of 2. M1V1 equals M2V2. Kind of reminds you of our P1V1 equals P2V2, our pressure and volume. All right, but this is just molarity and volume, so we have to find what the dilution of a solution is. So we want to make this solution, we either want to make the solution go up We want to make it more diluted, or we want to make it less diluted. So I'm going to give you a question. I am going to write this question down. Question number 1. How much concentration concentrated (18 molar) sulfuric acid is needed? You can write this down, you can take notes, you can do whatever there, to prepare 250 mils of a 6 molar solution. So what's needed to prepare? So when we talk about that, we're going to look at this and we're going to be given some different things here. How much concentrated 18 molar sulfuric acid is needed to prepare 250 mils of sulfuric acid? So we have to label. What is our M1? What is our V1? What are we looking for? M1, V1. M2, V2. In this situation, our molar of 1, because how much concentrated 18 molar sulfuric acid is needed to prepare. So this is what we're given to begin with. So our 18 molar is our M1. To prepare 250 milliliters of a 6 molar solution. Here again, M2, this is our second one. This is what we're going to. All right, 250 mils of volume of 2. One thing we said we know we have to do every time is convert this to liters, so that becomes 0.25 liters. Now, again, we've done stuff like this all year long. We plug this in and we can find this. This is also something that we could have done in the lab, something we take stock solution. We could have done this really easily. Taking 6 molar hydrochloric acid and turned it into 1 molar hydrochloric acid, or vice versa, we could have done this. So here we are given M1. Remember our equation, M1V1 equals M2V2. 18 molar V1 is what I'm looking for, equals 6.0 molar times 0.25 liters. Do our math. This equals 1.5 equal to 18 molar V1. Get V1 by itself. Once we do that, the volume of 1 ends up equaling 0.083 liters, or if we wanted it back to milliliters, we get 83 milliliters. Okay? Now I know that may be quick. You can pause it, you can stop it, you can see where what you maybe need help on. If you have questions, I'm going to have some time allotted so you guys can ask me questions. I'll post this to Google Classroom. It'll probably be through YouTube. Like I said, bear with me on this. The last thing I want to say is if there's anything you need as students from here at the school, from us at the school, don't hesitate to call us. I know we've said that, but really don't. If you need a way of getting food, you need a way of getting water, you need something when it comes to your health, please call somebody. You can call me, you can contact me, I can get you in touch with the right people, or I can come help you myself. We'll figure something out, I promise. Don't get overwhelmed by this. Know that if you're sitting here watching this, you're trying to get better, and I really appreciate you sitting here watching this and taking the time to better yourself, all right, to become more intelligent. Thanks, guys.